Moving on to exercise 4, we will be getting the relative hand rank after community cards have been played. So it's similar to the last one, but this time we have to pretend we're on the flop. We see 3 cards, or on the turn or the river, we want to see how many other 2-card hands is our computer card better than, right? So let's just look at a hand, for instance. And now we have, let's just say hand 2. All right, how many hands is this hand now better than? So now we have to consider the community cards. So the human can use the community cards, we can use the community cards. And we're gonna do the same sort of thinking. We're gonna iterate through all of the other possible 2-card hands that the human can have, right? So the hands are a little bit more limited because now the human can't have these 3 cards. It can't have these 2 cards either, right? So there's no repeated cards in a deck. So what we're going to do is remove these cards as possible hands and then try to create all the other 2-card combinations and figure out what is the hand ranking. So now we don't use our pre-flop score. We will use our evaluator class that we've already created and get that evaluation. So just let me just run this so we have it in memory. So the evaluator class works by giving it a hand, and we're going to do hand, this was hand 2 plus community like this. And so we don't even have a hand right now. We just have a high card jack. We can actually get the score. It has a score attribute like this. So this is its score. It's low. It's the lowest one. So it's score of 0. This is just the next highest rank, which is jack, and so forth. So we have to see, what we're going to do is we're going to create all these other 2-card hands, pass it into the evaluator, add the community cards together to see its 5-card poker hand score and see how many of those is it better than. So the first thing that we're going to do in our function is just find this score. So we'll just do current hand. Let's use another variable. So we'll say hand plus community. And then we'll just get the score. We're just going to use our evaluator, and we'll just say current hand like this. The next thing we're going to do is iterate through all of the other possible combinations of hands and figure out what their score is. So we can say other scores. We're going to get a list of all these other scores. And to do the iteration, we can do the same thing that we did over here. So the itertools trick. So we'll just copy and paste this here. Now, like I said, because these cards already exist, we don't really want to look at hands that use these cards. So we're going to actually remove some of these cards. Instead of using all 52, we can create a variable called cardnums. And we'll convert it to a list, so it'll make it easier for us to remove some numbers. So we want to remove some of these, whatever the jack number is. So we have to do a little bit of reversing here. So I'm going to say, so for card in current hand, and let me put a space here to separate out this logic. What I want to do is cardnums dot, we want to remove this. What we do to remove is just pass it in the number. So this is the numbers between 0 and 51. We have to figure out what is this number. So the card has a suit. We're going to multiply that by 13 and card dot rank. So that'll get it back to our number. So this is what we could have done when we created our hand class was actually just save this number. That would make it a lot easier. So remember, we had to use some division, like modulus division to get the suit, and integer division to get the rank, or vice versa, actually. So we're just getting it back in that number that we originally found it as. So that's all we're doing. If you go back over here to the card class right here, we could have saved this number, right? This is a number between 0 and 51 as an attribute, so we can access it directly. So that's probably a better way of going about it instead of trying to reverse this. I'm just basically reversing this arithmetic right here. I'm getting back that number. And so I just don't want to use these hands or use these cards over here. Okay, so that's fine. So instead of range 52, we're going to go through card nums like this. So we're going to get our hand, and then we're going to get the score. Actually, I shouldn't call it the same number. I should say something like other score, not scores, is evaluator of this hand plus the community, like this. So this particular hand, and I should call this other hand so I don't get it confused. I would overwrite that variable, so I don't want to do that. Other hand plus community, and I'll do dot score like this. And then I can say other scores dot append other score. So again, one more time, after I've removed the numbers that have already appeared, so we know the human can't have these 5 cards, I'm going to iterate through those 2 card combinations of those. There's going to be 47 left if we're on the flop, 52 minus 5. I'm going to create a hand of those cards. I'm going to pass that other hand with the community cards into the evaluator, get the score, and then append that score to the other scores list. All right, so after just doing this on the video, I figured out a better way of doing this, and I'm just going to keep the other part of the video in because sometimes it's good to understand an improved way of a solution. So this will actually save us some time over here. So what I'm going to do is I am going to have 2 other variables. One is I and the other is n. So for every combination, I'm just going to increment n by 1. And then what I'm going to do, I'm not going to have the other scores list. I'm going to say if our score is greater than the other score, right? So if the score for the computer's hand is greater than the other score, right, for all the other combinations, then I'm going to do I plus equals 1. All right, so n will just be the total number of other combinations. So this is like those 47 other cards, choosing 2 of them. That number is about 1,000. And then all I'm going to do is return a fraction. So I divided by n. I is the number of hands that we have beat. Right? How many of these other ones are we better than? Okay, so that looks good. Let's go ahead and see if this works now. So I've entered in our function. So this does not match over here, and we are going to get an assertion error. So what happened is that I tested whether it's greater than or equal to. So if we at least tie or equal to, it'll make a small difference because there will be some ties. Like there's other aces out there. That's what hand 1 is. So if the opponent also has ace, then there will be a tie. And so that's where this now matches. So I just changed it over here. I put a greater than or equal to. So it's just a very small difference in the fraction over here that it made. And then the others also work out well now. So hand 2, ace 8-7, is one of the poorer hands. It's only better than 12% of other hands. Hand 3 is now better because it actually has a pair. It is better than 78% of hands, so it has a matching pair of 5s. So you can see here that it was a worse hand pre-flop, but now it's a better hand post-flop because of that pair. All right, so that is the logic for this one, for exercise 4, getting the hand rank relative to all the others. One more thing is that the community can be more than just 3 cards, right? It could be the turn. I could just add some more cards over here. Like this. And so we'll get a different, ranking like that.